Hi, welcome back to my channel. Let's try to solve this problem. Count negative numbers in a sorted matrix. Here, what is sorted matrix? Sorted matrix is sorted in a row wise, sorted in column wise. Let me give an example. 4, 3, 2, 1, which is sorted in row wise, and if you see 4, 3, 2, 4, 3, 1, 1, 1 minus 1, it's sorted in column wise as well. Now, the question is we need to find the number of negative numbers in a sorted matrix. So, what is the first solution that comes to our mind? The brute force solution that comes to our mind. The first solution that comes to our mind is traverse each and every number and see if that number is a negative number and increase the count and return that count. But here we are not taking advantage of the rows or the columns being sorted, right? So how we can take advantage of it? Okay. Be- before going before going to that, what would be the time and space complexity of the solution that we just discussed, in which we are traversing each and every element? It would be O of n square, where n is row n and column n. We have it's a n square, right? It will be O of n square. So can we make use of can you make use of the array, the matrix being sorted? Let's look into it. How we can do it? So let's say the row is been sorted from here to here, and in the first row we found the sorted element here, and from here we know that all the elements below this are lesser than this, so that is it's sorted order. Yes, we for first row, for row 1 we found the negative number at this place, and we know that all the elements are in the sorted order from below here. So what we can do of this knowledge, in the next row, in the row 2, what we don't have to traverse all the elements, we can just traverse till here, right? In the above row we know that it's at the column 4. We don't need to traverse till column 4, we can traverse till column 3, and we can decide that it does it have a negative number or not. In this case we don't have a negative number in this place also. Still, our previous negative number column would be 4 only. So in the row 3, what we'll do, we'll still be traversing till here, because the row 2 we did not find any negative number at this place. In row 3 will be traversing till here, and we found a negative number at this place. And yeah, and we know that all the number below this will be negative, all the number below this will be negative. So next what we'll do is, at the row 4 we can just traverse till here, and we can decide what are the negative numbers that we have, right? So yeah, now let's look at what is the time and space complexity of this problem. Let's say we do, in the worst case it's still n square, because we don't find any negative number in all the places, let's say, and we in this case would still be traversing all the elements and all the rows. Yeah, in the worst case scenario it would still be O of n square, and space complexity we are not using any. So this is in the worst case, it's O of n square. Let's say in the best case scenario we found the negative number here only. If we found the negative number here only, we know that all the elements here are negative numbers, all the elements here are the negative numbers. We don't need to traverse of any numbers, and it would be of 1. So this algorithm 2 has two approaches, has two scenarios. One is best case scenario, one is worst case scenario. And worst case scenario it would be O of n square, and in best case scenario it will be O of 1. Space complexity, we don't we are not using any space, so it's a constant. Okay, so how can we optimize our worst case scenario? So here what we are doing, we are still doing a linear search, we are still going through all the elements here to get the negative number. So what we can do, we can use binary search instead of linear search. So what's the time complexity of binary search? Binary search complexity is log n to the base 2. Okay, we are doing linear search, we are doing binary search, and we are finding the first negative element, first negative number, and then returning the index of it. Okay, for each row we'll be doing that. And Yeah, and each row we can do it. We know that our binary search takes log n time, and for each row we are doing that. So what would be our worst case scenario in this case? N log n will be our algorithm's time complexity. And what would be the space complexity? We are not using any space, so it's constant. Okay. Yeah, so I have implemented this n log n solution. Let's have a look at it. So what we are doing, we are counting the number of negative numbers in the sorted grid. I am going through each and every row. I am getting the index of it for each row. What index? I'll come to this function how I implemented it. For each row, I am getting what index is the first negative number, and I am calculating based on the condition. If we find a negative number, we are adding, and if we don't find a negative number, we are just adding a 0. Now let's look at this function, get first negative index. Here what we are doing, here we will be having 3 scenarios. Okay, here we will be having 4 scenarios actually. What the first scenario? First scenario is our first number is only the negative number. So our mid is 0, our minimum is 0, and we find not the mid. Our first number is 0, and we came to our first number, that is it's still a negative number, and we just have to return that index, 0 index. Okay, what is the second scenario? Second scenario is we are at the negative number, and the number behind us is a positive number or a 0. So at that place also we'll be just returning that index. And the third scenario would be we are at the negative number and we still have a negative number behind us. So at that place we are not just returning the index of it, we still have to proceed. What we want the first negative number. That's why we are still proceeding with the binary search to get the first negative number. And what is the third scenario? We are not at the we are still at the positive number, so we still have to proceed towards the right side of the array. So that's why we are doing that. So yeah, here what all we discussed? We discussed 3 approaches. The first approach is traversing all the elements one by one and getting the count. That was the time complexity for it. It would be of n square, and that's a boost force solution. That's the first solution that comes to our mind. And what's the second approach? That is still a brute force approach, but still a bit optimized way, in a bit optimized sense. In that, what we are doing, we are seeing till where, what is the first negative in the above row, till where we are finding the negative number, and in the subsequent rows we are not going till that point. We are just going the negative number row minus column minus 1. I mean, we are not traversing all the way towards the rows. We are just traversing till some specific point. In that solution also, the worst case scenario is still O of n square, so we have to optimize that. And in third case, what you are doing, we are trying to optimize the linear search that we are doing. Instead of doing a linear search, we are doing a binary search, so that we find the negative number in a log n time, and we return the index at index of first negative number. Yeah. So yeah, we saw the 3 solutions, and we saw the implementation of the third approach, where we are doing a binary search for the rows, for each row, and returning the solution. Thank you.